Hello everyone, you are all welcome to lecture number 973 and today's topic is the manufacture of polyurethane rubber, or in other words we call it isocyanate rubber. This is a very special type of rubber, and this rubber is manufactured by treating polyalcohol with isocyanate, and this is not a simple polymerization reaction, rather than it is chain transition reaction where the small carbon chain are joined together with the help of the alcoholic hydroxy group and cyanide grouping, and in this way the ethane and ester, they are combined in the form of polyester or polyethylene to give the polyurethane rubber, or we call it isocyanate rubber. This rubber is not containing any unsaturation, means double bond. That's why it is very much resistant to atmospheric oxygen, that is oxidation, and also it is resistant to a lot of organic solvents. It's not soluble in many of the organic solvents, and it can react with concentrated acids or alkali. So as I have already told you that the polyurethane rubber or isocyanate rubber is not direct polymerization, rather than it is carbon chain extension, and this extension of small carbon chain into long polymer chain. So the property of polyurethane rubber depends upon the nature and property of the small carbon chain with isocyanate that is reagent. So number one, these polymers means isocyanate rubber, or we can say polyurethane rubber, are manufactured by reacting polyalcohols with di-isocyanates, not by usual polymerization but by chain extension process, that is called chain extension process. Hence in the formation of urethane rubber, big polymers are formed starting from small polymers. So small polymers, and that small polymers like polyethers or polyesters, they are combined together, and there will be extension of carbon chain rather than polymerization, and then there will be formation of isocyanate or polyurethane rubber are formed starting from small polymers. The short chain polymers, which are converted in the long chain polymers, are generally polyethers and polyesters. Number two, the chain extension reaction in short chain polymers is carried out by a reactive reagent such as di-isocyanate. So di-isocyanate, where CN group is there, and CN group will react vigorously, very fast with alcoholic group, that is hydroxy group, but it is called polyhydroxy alcohol, and the alcoholic group of the short chain polymers react with di-isocyanate group vigorously. React with vigorously with the hydroxy group, and a long chain polymer is obtained. The reaction is given here, OH, OH and P, and then CO, NR and CO, OH and that is your CN group, that is isocyanate group, and once they will combine, you will get urethane rubber, or we call it urethane polymer, and where the P stands for polymer, and outside bracket this small n, this it can vary up to 100 in number. Number 3, properties of polyurethane rubber. A, the properties of the final product depend upon type of original short chain polymers and on their chain length. In this manner, a wide range of polymers can be manufactured, from rigid to elastic polymers. So the properties of polyurethane rubber or isocyanate rubber, that is number 3. B, A I have already discussed. So di-isocyanates are also capable of reacting with some active hydrogen atoms attached to the polymer chain, leading to the cross-linking, and that is the main reason. That's why at the same time of the reaction, the vulcanization also takes place, because some of the hydrogen atoms in the chain, they can go for cross-linking, and that cross-linking means it is the vulcanization of the polyurethane rubber. Vulcanization both takes place in one stage reaction. Vulcanized polyurethane rubber can also be manufactured taking into consideration the vigorous reaction taking place between di-isocyanate and water, which forms carbon dioxide gas. So di-isocyanate and water, and that vigorous reaction, that is, there is formation of carbon dioxide gas in this reaction. When water is mixed with short chain polymer, this water is mixed with short chain polymer and di-isocyanate, foaming, polymerization and vulcanization take place. So once it is mixed like that, there will be foaming reaction, foaming polymerization, and at the same time vulcanization will also take place simultaneously, and foamed rubber is also produced during this process. Urethane polymers crystalline on stretching and hence have high gum tensile strength. Actually, this polyurethane rubber, when you stretch it, it is crystalline, and that's why it is having high gum tensile strength. C, they are highly resistant to oxidation because of their saturated character, means they don't have a double bond, all are single bond, that is called saturated. So once it is single bond and saturated, it is resistant to oxidation, and the oxidation which is present in atmosphere or air, that is the main reason, and they are also resistant to many organic solvents. D, they are attacked by acids and alkalis, especially concentrated and hot acids and alkalis. Polyurethane forms are light, tough and heat resistant, weathering resistant and chemical resistant. E, that is spandex. Spandex is also another type of rubber where 85% polyurethane is there. That is, it is formed with 85% of segmented polyurethane, and spandex is also known as lycra, varine, blue sea fiber is as a trade name. So this is the trade name of this spandex. The fiber is used in formulation of the garments, swim wear, surgical hose, orlon, decaron, yarn are wrapped around the elastic spandex fiber. So with this I will stop. Thank you very much for watching the lecture.